Hey guys, Miss Stans here. I'm hoping to keep this video pretty short. I'm just going to go over 4 questions with you, and then you would do some work on your own if you are in class, and then finish up at home. And those of you learning from home, you're just going to do your work at home. Please remember, send me questions. I haven't really been getting questions. You can copy the objective, and before you do the do now, I just want to point out that there is a typo in number 6. Right here should be a minus sign. Your number 6 and your number 5 say exactly the same thing. You have a plus sign on both of them. So I'll put a minus sign on your number 6 so that it looks like this one. So hit pause, do the do now, and then turn it back on and make sure you got the right answers. So I am going to go through it rather quickly. You're supposed to send me questions if you have them. This is 8x to the 4th. This is 6x squared. So you got to be careful between multiplying and adding. Number 3 is 21x to the 5th. Number 4, you could do the box method, or you could do all of that distributing. It is multiplication. So it turns out to get you, let's see, I'll do a box for you. This is x squared and a positive 4, x squared and a negative 3. So we get x to the 4th, negative 3x squared, 4x squared, and a negative 12. So x to the 4th minus 3x squared plus 4x squared minus 12 combines to be x to the 4th plus 1x squared minus 12. That's the final answer. Number 5, it's the same binomials, but this is adding. So to add, you have to combine like terms, but to combine like terms, you have to get rid of parentheses. So there's a 1 in front to distribute, to remove the first set of parentheses. There's a positive 1 here to distribute. That removes the second set of parentheses. And now we can combine these like terms, x squared and x squared make 2x squared, and 4 and a negative 3 make a positive 1. And on number 6, subtracting of polynomials. Again, we want to combine like terms, but you can't combine terms until your parentheses are gone. So we'll distribute this 1 here to get x squared plus 4, and we'll distribute this negative 1 to get minus x squared plus 3. Combine the x squared with the negative x squared, and it's a 0x squared. So we don't write down any x squares. If I write down 0x squared, that's not considered simplified. If I have 0x squares, I really just have nothing there. It's a 0. And then I can combine the 4 and the 3 to get a 7. So final answer in this case is just 7. There shouldn't be an A here. Not sure what that is all about. Negative 5x in parentheses squared means negative 5x times negative 5x. So it's a positive 25x squared. Number 8, 5x in parentheses squared means 5x times 5x, which is 25x squared. And number 9, these parentheses squared means I do x minus 5 times x minus 5. Since it's a binomial times a binomial, I could do the box method to get x squared minus 5x minus 5x plus 25. These are like terms that I can combine. Final answer is x squared minus 10x plus 25. Number 10 is x to the 7th. Number 11 is 2 to the 5th. And number 12 I'm going to fix my negative exponent first. So I don't want this x to the negative third there. I mean y to the negative third. I want a y to the third in the denominator. So in my parentheses, I have x squared over 5x y to the, it's now going to be fourth power, but I just noticed that I can simplify those x's before I worry about that exponent on the outside. I can simplify out one x from top and bottom, so I'm left with just an x in the top. So I have x over 5y to the fourth, all raised to the second power, which really means I have x over 5y to the fourth times x over 5y to the fourth, which gives me x squared over 25y to the eighth as my final answer. This really are all the basic problems that you need to know. Notice I called them basic. You really do have to know how to do this stuff. This is the basics. On your test, they're going to be in application kind of problems. They'll be in with like area type problems and things like that. So you have to know these basics. There were a few questions I wanted to do with you. I just want to look back again because I can't remember. 1, 2, 4, and 6. 1, 2, 4, and 6. So when we're dividing a polynomial by a monomial, we like to rewrite it as a division of, as the sum of divisions of monomials. Let's just take a look at my objective again, right? We're going to rewrite the problem as the sum of monomial division. So what that means is this denominator actually goes with each part of the numerator. So if I rewrite it, I write it as 8n to the third divided by 2n plus 4n divided by 2n. I rewrote it as the sum, that's what the plus sign is all about, of monomial division. Right now, I have a monomial divided by a monomial right here. And when I do monomial divided by monomial, I really do it more like simplifying fractions. So the 8 and the 2 can simplify to 4 over 1. N to the third over n simplifies to n squared over 1. Right? They both had an n in common. If I simplify this next monomial division, 4 over 2 is 2 over 1. N over n is 1 over 1. So now I write down what I have left. I have 4n squared over 1, but you know you don't need denominators of 1 written down, plus 2. And that is my final answer. So if you can do monomial division, you know, like number 12 was like a complicated monomial division even. But if you can do monomial division, you can do this division of a polynomial by a monomial. So number 2, this denominator goes with each part of the numerator, so we rewrite it as 6x to the fifth over 3x to the third plus negative 9x squared over 3x to the third. I like having a plus sign in between, so I gave this minus sign to that negative. And if I simplify, 6 over 3 is 2 over 1, and x to the fifth over x to the third, there's more x's in the numerator. I'm left with x to the second over 1. And then negative 9 over 3 is really negative 3 over 1. And I have more x's in the denominator here, so this simplifies to 1 over x, because there were 2 x's in common, top and bottom, and I was left with a factor of x in the denominator. So my answer is 2x squared plus negative 3 over x. I'm also allowed to write it as 2x squared minus 3 over x. That says the same thing. Now number 4, when it's written with a division sign, I actually rewrite it like how I did number 1 and 2. This divides into each part of the numerator. I'm going to erase those lines. I don't want you to think I'm distributing. There is no such thing as distributing when you're dividing. It's like I have an 8r to the 4th plus 4r squared minus 20r, all divided by 4. I just can't see that exponent. Oh, there isn't an exponent. All divided by 4r. So if I rewrite it, I have 8r to the 4th over 4r plus 4r to the 2nd over 4r plus negative 20r over 4r. And now I'm going to simplify. So 8 over 4 is 2 over 1. There's one r in common, top and bottom, so I'm left with r to the 3rd over 1. 4 over 4 is 1 over 1. One r in common, top and bottom, so I'm left with r over 1. And negative 20 over 4 is really negative 5 over 1. And there's an r in common, top and bottom, so I'm left with 1 over 1. So we're left with 2r to the 3rd plus 1r plus a negative 5. Final answer for number 4. And number 6, I can rewrite it as negative 18x to the 7th over negative 9x to the 3rd plus negative 9x to the 3rd over negative 9x to the 3rd. So if I simplify this, I get 2 over 1, right? Negative over negative is positive. And there is an r to the 3rd in common, top and bottom. So I'm left with, an x to the 3rd. So I'm left with x to the 4th over 1. And negative 9 over negative 9 is 1 over 1. R to the 3rd over r to the 3rd is 1 over 1. So my final answer is 2x to the 4th plus 1. Some people leave off that plus 1. Remember, to simplify to be 0, a number divided by itself simplifies to be 1. And I think after doing those problems, you should easily be able to do the rest. So you work on it, you finish it for homework, and you submit this entire lesson, all 3 pages. Have a good day. See you. Bye.